All right, now the application of the galvanic cell is actually the battery. So we have a galvanic cell first, and the battery comes after. And they are the same thing, the same concept there. Just a little bit of detail. So the batteries are also called the electrochemical cells, are powered by chemical reaction where the oxidation reaction occur at one location and the reduction reaction occur at another location, just like the galvanic cell, right? So oxidation, electron flow to and cathode, the reduction reaction, and that's electricity happen there. Okay, so we used half reaction to describe the changes in taking place in each side of the battery, which just like we just did at the galvanic cell. Okay, so let's talk about the history, maybe just a background of the battery real quick. Okay, so first off, so Galvani, Luigi, but I don't know how to say his name. So Galvani, that's we call galvanic cell. He and his wife. Oh, by the way, so he's a physicist, biologist, philosopher. I don't know how does a one person could be anything? How could one person could be pretty much everything? Physician, physicist, scientist, whatever. So he and his wife discover animal electricity, where he can make dead frogs twitch when it's stuck by electrical spark. Okay, this field of study grows later, and we called it a bioelectricity, where they study the electricity produced by nerves in cell. Okay, so bioelectricity right there. And not far from him, so we have Alessandro, whatever his middle name is, that's a long middle name, and Volta, that's his last name. Okay, was an Italian physicist as well, and a chemist and a pioneer of electricity and power. So Volta thought that the animal electricity, so he heard the news, by the way, so whether the dead frog has come to alive, whatever. Anyway, so Volta thought that the animal electricity was actually a phenomenon of the contact between metal and moist material. Okay, so he started building his cell. All right, so we have the battery cell. This is the very first battery. So he got a copper plate and zinc plate connected with pasteboard or leather moistened with brine or vinegar. So we got an acid in here, in the pasteboard right here between zinc and copper. And this is called one cell. And we got 2 cell, 3, 4, 5. We just build onto that. Okay. All right, let's look at the real one. So this is the his cell. So there's 6 cells total. Look at the voltmeter. So voltmeter is actually not at 0. This is at 0 right here. So it goes to the right a little. So it produces some electricity. Now increase the number of cells from 6 to 11. Look at the meter. So go to the right more. Now 11 go to 16. More electricity. Go to 21 and go to 26. Right? So totally this is the mark of the first battery that we had. Okay, so he called them voltaic pile, so called after his name. All right, he thought that zinc is oxidized by copper, but that's actually not true. The pasteboard right here, of course, is moist, so that's the solution, but the solution has no copper in it, no copper solution in it. Okay, so there's no copper. The zinc is not oxidized by copper, but in reality, this is what really actually happened. Zinc is oxidized, so release the 2 electrons, become zinc ion, get to the pasteboard, which is moist, right? So soaking wet. But in this pasteboard, it's soaked with an acid. There's acetic acid, right? So the acetic acid, so an acid can oxidize zinc and take the 2 electrons and become hydrogen gas. Okay, so I would like you to pause the video right here. Can you write the oxidation and reduction half potential, right? And then the redox reaction from here. Okay, what happened with the zinc? What happened with a proton? And what's the redox reaction look like? Okay, all right, let's do. So oxidation reaction. So zinc loses 2 electrons, becomes zinc 2 plus, not zinc ion. And the reduction, so proton takes the 2 electrons, so 2 of them take 2 electrons, 1 each, and become the hydrogen gas. Okay, and yep, that's it. That's what happened. All right, so that's the first battery. Okay, And then we have the battery evolve. So we will try to improve the battery. And we got to the next one. Look at the dry cell battery on the next video.